Hey there, welcome back to the channel and let's write the problem subarray sum1. So in this problem, we are given with the array of n positive integers and our task is to count the number of subarrays having sum is equal to target sum. So let's take an example. Here n is equal to 5 and the target sum is equal to 7. And we are given with the array of numbers 2, 4, 1, 2, 7. And our target sum is 7. So we need to calculate these subarrays. So one subarray I can clearly see is 2, 4 and 1. If you add this, this is going to give you 7, right? So this is one subarray. What can be other subarray? This can also be a subarray where 4, 1, 2. 4 plus 1 plus 2 is equal to 7. So this can also be a subarray. And one subarray can this also, right? Just a single number. Subarray can contain a single number also. So this can also be because its value is equal to the target sum. So this can be our also answer. So output we have to print is 3. Now one direct approach or the brute force approach would be very simple. Use the two loops, traverse through the array, taking one start and then calculate the current sum. Make the current sum equal to 0 and start increase the outer loop and again start the inner loop. So like this you can do, and that would be O of n square. But can we do this better? Can we do this? Can we do some optimization? Yes, we can do, and let's study that. So here again the same situation is given. Now we are going to use two pointers approach. So here will be one pointer and the other pointer. So let me call this left and right. Now one thing, let's make it little gamify model, and instead of calling it left I call it a left warrior and a right warrior, and this array is our war zone. So basically this war zone specify that we have to this right warrior is going to fight in this war zone. Fight means it is going to accumulate the sum, and if it is equal to target, we have found one answer. So let's start. So right now right warrior has to go up to n, right? So right, left and right both are standing, and right has to go up to n, and we will do the operation. Basically this right warrior is going to fight, and it is going to make sum as equal to 2. So our it is not equal to target sum, right? So left right warrior is again going to move forward. This is right, this is left. So right plus plus. So left, and now the sum will be 2 plus 4, which will be equal to 6. It's still not there. Again it is going to move. 6 plus 1 is equal to 7. And now you can see that it is equal to target sum, right? So our left is here and right is here, right? So let me erase. So left is here, right is here, and our sum is equal to 7. So this is one answer, right? So in this left and right, you can think of now instead of pointer they have formed a window. This is a window in which our answer is present. In this our answer is present. That means what I can do is now I can increase our count. So because we have found one answer, so our count will become 1. And now I will make this window slide. Why slide? Because I know the sum of this is equal to 7. Adding this guy will do any change or not? We have to see. Maybe adding this guy, if I slide this, we know this is equal to 7. Now what about this guy? Adding this guy, is it equal to going to make the target sum? We have to check. That means I have to slide this window. Left is here, right is here, and I'm going to slide. So what would be the sliding logic? This left is pointing, left warrior is pointing. It should not point here, right? It should point here now because sliding operation is done. So sum was 7. So I will remove 2. Why 2 removing? Because this window is sliding. So this will become to 5. Correct? So sum is 5. This done, and left is increased, and right, no matter what, it is going to increase because it is going to go up to the end of the array. So left is here. Let me erase this. So now left is here, right is here, and our window is going to slide. Now again we will do sum. So sum was 5, right? We removed this. It was 7, but when we removed this, sum became 5. Now we will going to add this guy. So 5 plus 2 is equal to 7. Great. We have found one or more answer in this window also. That means adding this guy resulted in our sum being equal to target. So count will become now 2, and again do the same process. Wherever the left warrior is pointing, remove it. That means 7 minus 4 will be 3, and increase the left pointer. So left is going to be pointing here and right is going to be pointing here. Okay, so I'm erasing again, and our sum is 3. So let's write quickly. Sum is 3, and our left is here and our right warrior is, again we will do the summing operation. So this will be 10. Now adding this 7 has increased our answer, right? No matter what you do, this is not going to pull down the number, considering we don't have the negative numbers, and this is where this algorithm fails. We are assuming that we have positive numbers. So as we are going to increase our window, the sum has to increase only in this portion. So now this has become very huge, right? Very huge. That means now I have to decrease. And how can I decrease? How we were decreasing? You remember we were removing from the left portion. So again we are going to remove from the left portion. So right is here. Now since our sum is greater than target and our left is also smaller than right, I can do sum minus wherever left is pointing. So 10 minus 1 is equal to 10 minus 1 is 9, and we will increase our left. So basically this piece of code we are going to write. Sum is 9 and left will be here. Again, sum is 9 and it is greater than our target, which is 10. Sorry, it's not 10, it is 7, which is, so again we will do, and this is equal to 7, and we will increase our left. So left is here. That means you saw we decrease the window, right? Window has become now this. Window was earlier this big. Now we have decreased by decreasing the left warrior, by increasing basically the left warrior to the right side. Now sum is 7. It is greater than 7. Our target is no. That means what we are going to do, this piece, this is going to break, and we will be here. And sum is equal to our, we will increase our count. So count will be our 3, which was our answer. And we will take out the left. We will increase the left and we will increase the right. But this condition will break and we will exit the main loop. So this was the sliding window explanation. We assumed that there is no negative numbers, and that is why this problem will break if you put the negative numbers. And whenever the target, whenever our sum became too heavy, we start removing from the left side, because we know that we are going to shrink the window by removing the left portion. And why we are not removing from right portion? Because right still can has the chance of having the target sum, in which in this case it was right, it was having this 7 at the right portion. But no matter what, or even if you had 7 even here also, so whenever our sum will become heavy, we will start removing from left, we will start shrinking the left this window. So by increasing our left warrior, and we will somehow reach this, because right warrior is our main warrior. It is fighting the war zone, and left is just following it. So this was the easy explanation, and let's just write the same code which I have written and push it on the server. So we have the target sum, we have the number size, and we have the array. We inputted the array and we call this sliding window function, which is this. It is going to just return us the count, and you can see this is the same thing which I showed you just now, same thing. And these are warriors, left warrior, right warrior, and we have the count and our sum till here. We will go up to n, we will keep on adding, and as soon as hit the target, we increase our count, we slide our window. No matter what, right warrior has to move forward. And at any point of time, if we know at any point of time, if sum becomes heavier than target, and while still we have left is equal to right, we start shrinking the window, because maybe at the right portion we have the number which may be the target itself or may not be. So we are going to shrink, and as soon as it becomes less, we again start increasing the right warrior. All right, so let's just try to submit this. So it has been accepted.